Today we're going to look at buffers, and buffers deal with acids and bases in the fact that they will keep the same pH even when you add an acid or base to it. However, of course, it can only handle a certain amount of acid or base, but it will maintain the same pH even if a little bit of acid or a little bit of base is added to it, because we know that if you add an acid to water, it immediately will become acidic. If you add a base to water, it will immediately become basic. But in a buffer, it will be able to maintain that same pH and will not change. So we have either an acidic buffer or basic buffer, and both of these buffers work fine for acids or bases. So an acidic buffer can work for an acid, an acidic buffer can work for a base. A basic buffer can work for an acid, a basic buffer can work for a base. It doesn't really matter. And what they both are they're going to be either weak acids or weak bases, and then it's salt. And so we have a weak acid here. This is CH3COOH, which typically, I know you think of the OH being a base, but this is an acid. It's just a different way of being written. So this is the weak acid. This is acetic acid, which is in vinegar. And then you have its salt. So the salt is just the conjugate of it. So this would be the conjugate base. Since this is an acid, this would be the conjugate base, because you notice that it lost an H+. Then a basic buffer is the weak base, so NH3, ammonia is a weak base, and then its salt, also known as the conjugate acid. So as you can see here, it went from NH3 to NH4+, so this gained an H+, so that's why we know this is going to be the base. So when we have a buffer, it's either going to be a weak acid with the conjugate base or a weak base with its conjugate acid. And what it does is that when you have an acid and you try to add it to the buffer, that negative ion on the buffer is going to combine with that hydrogen. That hydrogen has a positive charge, and we all know opposites attract. So therefore, that hydrogen is going to want to go with the negative ion instead of water, because we know normally when you add it, an acid, that H is given off and it goes right to the water, forming hydronium. But instead what's happening here is that hydrogen is going to instead go to that negative ion, because that's more attractive than a neutral substance, because it's got that positive charge on it, that hydrogen does. So it's going to want to go to the negative. So because that hydrogen ion is not combining with the water, we are not increasing our amount of hydronium ions. So therefore, our pH will remain the same. So a great analogy for this is when we only had our Citgo gas station across from North. And then people would go there for gas. But then QuikTrip comes along. QuikTrip is shiny, exciting, and so it's got free stuff there when they first opened. And so then people started going to QuikTrip instead of Citgo, because QuikTrip looked more attractive to it. Well, the hydrogen is more attracted to the buffer, aka QuikTrip, than it would be to water, aka Citgo. So, and then eventually what happened? Well, the Citgo closed down its gas station, so because not enough people were going there to get gas. So the hydrogen ion does the same exact thing. So it's more attracted to the buffer than it is water, because the buffer's got that shiny negative charge on it, and hydrogen is positively charged, where water is just neutral. I mean, it's okay, but it's no QuikTrip. So therefore, that hydrogen is not going to form any more hydronium ions, which we know affects the pH. Then how do they work when acids are added in an acidic buffer? Here's our hydrogen ion being given off, okay, from whatever acid it is, HCl, H2NO3, doesn't really matter. And what it's doing is it's combining with the conjugate base here. So we said that in an acidic buffer, you're going to have the weak acid and its conjugate base. So here's the conjugate base right here, and it's going to combine with that hydrogen being given off from the acid, and then it's going to form this substance, which is not H3O+. So it's something different. So therefore, it's not going to change the pH. if we have a basic buffer, here's our weak base, and then here is the conjugate acid of that, and then here is the conjugate base. So once again, that shiny negative charge is going to be attracting the hydrogen to it, and so it's going to form water, and water does not change the pH of a solution. So if we're just forming water, we don't change the pH. Now, what if you add a base to a buffer? How does that work? Well, if a base is going to be added, that negative hydroxide is going to be attracted to that hydrogen ion that's available in there, and then we're going to form water. So water will not change the pH. So because we don't have any extra hydroxide ions in there, our pH will not change because we know hydroxide refers to bases. So when we have our acidic buffer, here's our weak acid right here. This hydrogen is going to come off the weak acid, combine with the OH, and then we're going to form H2O. We're going to form water. Then in a basic buffer, we add a base to it. It's giving off those hydroxide ions. Well, here was the conjugate acid of that basic buffer, and so therefore that hydrogen is going to pop off of there and then give the hydrogen to the hydroxide and form water. So even though we're adding a base to it, our hydroxide ions are being absorbed by that either the acidic buffer or the basic buffer. So they both are absorbing the hydroxide ions, therefore the amount of hydroxide ions doesn't change, therefore our pH will not change. Now, of course, we know that this can only work up to a certain point because after all of the weak acid is used up or the conjugate acid in a basic buffer is used up, once there are no more hydrogens to cancel this, then the pH will change because then there will be excess hydroxide ions in here. But until that happens, the pH is just going to stay the same. So as long as you have buffer available, it's going to be able to cancel out that hydroxide ion in here by giving away a hydrogen, forming water, which does not change the pH. And stop.